So apparently the last problem didn't actually even have a number, so it was double messed up. Whoops, my bad. Oh well, we will all survive. Use a unit circle to explain why sine is an odd function and why cosine is an even function. That one is pretty straightforward. If you think about a little reference unit circle, let's call that some positive angle theta, and then let's compare that to some negative angle theta. If we think about the x values here, we have the x value is cosine of theta, the y value is sine of theta, and then here we have the x value is cosine of negative theta, and the y value is sine of negative theta. But what do we know about these two x values? We know that they are the same, because if you think about the symmetry there, they share that base, those two triangles. Cosine is the adjacent side of that triangle, the x value. So we know that cosine of theta equals cosine of negative theta, which means that's what's basically saying f of x equals f of negative x, which is the definition of an even function. If you think about the two y values there, if that's y, then this would be negative y. Those values are opposites, and so we can say that negative sine of theta equals sine of negative theta. And that is the definition of an odd function. Negative f of x equals f of negative x. And so sine is odd. Now B, use the even and oddness of sine and cosine to show algebraically that tangent is an odd function. So let's start with tan of negative theta. Let's rewrite that as sine of negative theta over cosine of negative theta. But we know that sine is an odd function, which means I can rewrite it as negative sine of theta. And we know that cosine is an even function, which means I can rewrite it as cosine of positive theta. Well, sine theta over cosine theta is tan theta, and we have that negative out front, so we get negative tan of theta. So what we have is, from the left, we have f of negative x equals, on the right, negative f of x, which is the definition of an odd function.